In this example, we are going to perform set operations. An operation in arithmetic or algebra is where you have an addition, subtraction, multiplication, or division of values that produces another value. So set operations are similar, except rather than using addition, subtraction, multiplication, and division, we wind up using complements, intersections, unions, and differences of sets to produce a new set. And that's what we're going to do here. So we have this universal set, and as you can see here, it contains the elements 0 through 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we have these subsets here, set A, B, and C with these various elements. And then we have these operations that are going to go on that are going to produce a new set, and we have to identify what that set looks like or what the elements are. So we have set A intersects, that's what that upside down cup is right there, that means intersects. So set A intersects the complement of set B. So since I have a complement here for set B, I also have a complement here for set A, and I have a complement here for set C, I'm going to need the complements. So I'm just going to go ahead and I'm going to list the complements up here. And don't forget, the complement of a set is everything that's not in that set. So I'm going to put in a complement here. And again, that's going to be everything that's not in A. So you can see we have 2, 4, 8, 9, and 10 in A. So everything that's not in there, that's going to be 0, 1, 3, 5, 6, and 7. And I think we got it. So that's the complement of set A. And I'm going to do that for the remaining sets here, for set B and for set C. So now that I have the complements for each of these subsets, I'm going to take A, where does that intersect the complement of B? And of course, the intersection means where they both contain the same elements. So as you can see right here in set A, I've got a 4 right here. And then in B complement, I have a 4. And then in A, I have a 9. And then in B complement, I also have a 9. And those are the only elements that they have in common. So A intersects B complement, has the elements 4 and 9. Now what we also have to do is, once we determine what these elements are, we have to illustrate that using a Venn diagram. So whenever we have 3 subsets, these subsets are all going to intermingle sometimes, so they're going to overlap. So I start out with making a set A, and it's just going to be a simple circle, nothing fancy. So this circle is going to represent set A. Then I have to make a similar circle that represents set B, except it's going to overlap. And the reason the circles overlap is because some of the elements in set A are also in set B. And then I'll do one representing set C, and that's going to overlap A and B. And here's our set C. Now these 3 subsets sit inside the universal set, so I'm going to put a universal set, these sitting in a universal set, and we'll do that by making a rectangle around these sets. And I'm just going to label this rectangle as U so that you know that it's the universal set. Now what has happened when we make this Venn diagram with 3 intersecting sets is it creates these regions. We have a region right here. I'm going to label it as region 1. We have a region right here. That'll be region 2. 3. 4. 5, 6, region 7, and then the last region is the region out here. This represents all the elements that are not in any of the subsets. So we have these 8 regions. Now what I'm going to do is I'm going to fill our Venn diagram here with all the elements. So the simplest way to do this is to start right where all three overlap. That's going to be in region 5 here, right in the center here. So that's where sets A, set B, and set C all contain the same elements. So as I look through these three subsets here, I can see that A has element 8, so does B, and so does C. And that seems to be the only element that all three share. So I'm going to put in here 8. Then the next thing I do is where two of the subsets overlap. So that would be this region right here. If I did sets A and B, this is where they overlap right here. So now I look for all the elements that are both in A and B, the same elements. So in A, I can see I've got a 2 here and a 2 here. I've got an 8 here and an 8 here, which is this 8 right here. And then I've got a 10 and a 10. So those are going to go out here. 2 and 10. So as you can see, that's the intersection of set A and B, 2, 8, and 10. I'm now going to do the intersection for set B and set C. That would be this region right here. So I go ahead and I look for what's in B and in C. And you can see I have 7 and 8. And again, 8 is already accounted for where the 3 overlap. So then 7 is going to go right here. And you can see that's the intersection of sets B and C. I continue this with doing sets A and C. That's going to be this region right here. I've got a 4. And of course the 8, and that looks like it. So 8's already accounted for, so 4 is going to go right here. And there's the intersection of A and C. Then what I do is I fill in the remaining elements for each subset. So for A, I already have 2, 4, 8, and 10. 2, 4, 8, and 10. I still have element 9, so that's going to go out here. And as you can see, there's all the elements for set A, 2, 4, 8, 9, and 10. I do the same for B. I already have 2, 7, 8, and 10. 2, 7, 8, and 10. I'm missing elements 1 and 3. Those are going to go out here. And there you can see them. And then I'm going to do the same for set C. I already have 4, 7, and 8. 4, 7, and 8. I'm missing elements 0 and 5, so I'll put those out here. So I have 0, 4, 5, 7, and 8. So now I've got almost all the elements accounted for. 0, 1, 2, 3, 4, 5, but I don't have 6 because 6 isn't in any of the subsets. But 6 is still an element of the universal set, so that's going to go out here. So now this is the Venn diagram that represents the universal set with its corresponding subsets. So now to illustrate letter A here, where A intersects B complement, I'm going to fill in these elements here, where these elements are right here. So that's the Venn diagram that represents letter A. And we'll continue. Now we have A intersects B complement. Now we're going to find the intersection of A and B first and then find its complement. Now we don't necessarily have to use the sets up here. We can, but we could also use the Venn diagram to help us. A intersects B, that's this right here. That's 2, 8, and 10. Well, I don't want 2, 8, and 10. I want the complement to that. So that's going to be everything else. So that's going to be 0, 1, 3, 4, 5, 6, 7, and 9. To represent the Venn diagram, and that's the Venn diagram that represents A intersects B all over complement. And we'll continue. Here's letter C. A intersects B, and where that intersects C, this is where all three intersect. Again, we're just going to use our Venn diagram, and that's 8. So this becomes 8. The corresponding Venn diagram. And there it is. And we continue. We have A intersects B union C. So we kind of maintain the order of operations. We're going to do what's inside the parentheses first. So B union C, I'll write that up here. That's all the elements in B and C. Again, we could either go through here in looking at the set elements here, or we can go ahead and look at the Venn diagram. For the Venn diagram, everything that's in B and C. So we have 0, 1, 2, 3, 4, it looks like. Five, 7, 8, and 10. So that's B union C. I want to see where that intersects with A. So all the elements that are in B union C that are also in A. So if I look right here, here's B, here's C, and where do they intersect A? That's right here. So you could see that it is 2, 4, 8, and 10. The corresponding Venn diagram is we'll just go ahead and fill in that region. Okay. We'll continue with E. Again, we have A complement union B complement. That's in parentheses, so we'll find that first, do what's inside the parentheses first. And where does that intersect set C? So maybe it's easiest, now that we have our complements up here, let's just go ahead and see what's in A complement and B complement. And we have 0, 1, 3, 4, 5, 6, 7, and 9. Now we want to see where this intersects C. So all the elements that are in this right here and in C, it looks like 0, 4, 5, and 7. So the corresponding Venn diagram, 0, 4, 5, and 7, so it would be this region right here. Let's move on to F. So we have all the elements in A and all the elements in B. Take out the elements in B that are in common with A, and then we have what's left over. So we'll do A minus B. Don't forget we're going to do what's in the parentheses first here. So all the elements in A. So what I'll do is I'll look at what's in B and take that out of A. I've got a 2, an 8, and a 10. What's left over is 4 and 9. So I'm going to union that with the complement of C. So I'll have 1, 2, 3, 4, 6, 9, and finally 10. Of course, the corresponding Venn diagram. I just kind of highlight 1, just to give me an idea of what I have to color in. 2, 3, 4, 6, 9, and 10. So I'm going to color in all of this. And there you go. Let's move on to G. So we have C minus A complement. That's in parentheses. We'll do that first. And then union B. So we'll do C minus A complement. So everything that is in A complement, I'm going to take that out of C and see what's left over. So A complement, I have a 0. I have a 5. And I have a 7. So what's left over is 4 and 8. I'm going to take that, I'm going to union that with set B. So B, I have 1, 2, 3, 4, 7, 8, and 10. So that'll be 1, 2, 3, 4, 7, 8, and 10. And again, the Venn diagram, I just highlight what they are. 1, 2, 3, 4, 7, 8, and 10. Then I can get an idea what to color in. And that represents the Venn diagram. Finally, we get down to letter H. we can see that we have A intersects B complement, that's in parentheses. And then we have A complement union C, that's in parentheses. And then we're going to find the intersection of these two. This one right here we already have done. A intersect B complement, that's this one right up here. So I'm just going to go ahead and repeat it here. A intersects B complement. That's at 4 and 9. Then I'm going to do A complement union C. That's all the elements in A complement in C. So we have 0, 1, 3, 4, 5, 6, 7, and 8. Now I'm going to find the intersection of those two. I'm going to find the intersection of this here. That's right here. With this grouping here. That's right here. So the intersection is going to be 4. And that's it. And you can guess what the corresponding Venn diagram will look like. So that right there is A intersect B complement, where that intersects A complement union C. And I think we're done.